Okay, so 2.3 is talking about finding domain and range. So let's just recall what domain and range are first. Okay, domain is going to be whatever the x values of your graph is, and the range is going to be your y values. So this is what number 1 and number 2 look like in section 2.3. So when you're talking about the domain and you are just giving a list of points, like number 1, it just wants to know what are the x values of all those points. So you're just literally listing the x values of those points. So let's see. What I could do, because it's going to eventually ask me the range. This is going to be a 4-part question. So it's going to ask me the domain and the range within those 4 parts. So let's just name all these points with their ordered pair. Okay. So let's see, starting on the left, this one's point, and again, if you have it printed off that I sent you, it probably is more clear than my freehanded drawing, or if you have it pulled up. Okay, this one's point is where? It's at -4, 6, right? That's where that point is. It's at -4, 6. That's its x, that's its y. This one's point is at, to the left 3, up 5. So -3, 5. This one, -2, 4. -1, 3. This one is at 0, right? Left or right, 0, up 4. So 0, 4. This one to the right 1, up 5, so it's at 1, 5. This one's to the right 2 and up 6. So 2, 6. So when it's asking you the domain, it wants you to just list all the x values. So -4, -3, -2, -1, 0, 1, and 2. So there's your domain. The range is the y values. And if you have more than one number that just is the same, you'll need to repeat it, right? Because some of these y values are going to be the same. I've got 6, 5, 4, 3, and then I've already got 4, I've already got 5, and I've already got 6, right? So I don't need to repeat myself. So the range is just 3, 4, 5, and 6. Okay, now the other parts of this question are going to ask me something different. What is this? The first part says, what is f of -2? So in other words, what's the number that's always inside these parentheses? It's always the x value. So it wants to know what is the y that goes with that. So I can either, now that I've listed out all these points, I can just go find the y when the x is -2, or I can look at the graph, whatever. So let's see, where is x -2? There's where x is -2. Its y is 4. So 4 is what the y is when x is -2. Now make sure there's no other -2 in the x spots, and there's not. And if I'm looking at the picture when x is -2, which is right here, it wants to know what are the y's that are lined up with it. What's that y? 4. So you can either look at it in the picture, or if you've already listed all the points, which I personally think is easier, especially when it's a freehanded drawing, is just to go through the points and find where your x is -2 and the y is that answer. Now, the next, or the last part, says what are the x values when f of x equals 4. So when f of x equals 4, so what is f of x also called? Y. So when y equals 4, so you can, again, you have your points listed out, go through and find any points where y is 4. Let's see, 6, 5, there's 1. What? So where y is 4, what is x? Negative 2. Let's see if there's any more where y is 4. There's 3. There's another 4. So what else is x? 0, 5, 6. No more 4s. So when y is 4, it's going to actually line up with negative 2 and 0, because where is y 4? Right here, right? Well, there's where x is 0. Any other where y would be 4? This one right here, which is lined up with what? Negative 2. So that's why it's negative 2 and 0. You can look at it either way, either at the graph, or if you've named all the points, just look at your points. All right, number 2 looks like this. It's going to ask me the same kind of questions. So the difference between this graph and the last graph is my number 1 was just points that weren't connected. This one is continuously connected, right? So my domain means what are my x values? Well, let's see. What is this side of the, when it starts here, what does it do? Goes forever to the left. That's what that arrow means. It's going forever to the left and up that way. This way is doing what? Going forever to the right and up. So did I say forever left and forever right? What is this one doing? Forever left, forever right. If you're going forever to the left and to the right, your x values are all of them, right? This is eventually, here's my x-axis, here's all the x numbers. It's going all the way left and all the way right. So it's eventually going to cover the whole thing. Okay. So there's different ways that are said. It could, we'll get into it later, but you could say negative infinity to positive infinity, all real numbers. This one's multiple choice, and one of the choices is the domain is all real numbers. If your arrows go forever to the left and forever to the right. Let me show you one that would not be all real numbers. That's not just a group of points. Like for instance, a square root graph looks like this. That's what the graph of a square root function looks like. That one would not be all real numbers. This one, it starts here, and I only have one arrow going forever to the right. It starts where x is 2. So your x's are only 2 and greater, right? X is not ever -1 or 0 because it doesn't go to the left. It starts right here and just goes right. So that's what it would look like on a graph. If it wasn't all real numbers, it would stop at some point going one way. Now, like this range. Look at this range. It's not going to be all real numbers. Go ahead. Absolutely. It'd be greater than or equal to 2 would be that domain. Is exactly right. Now, this one's range, which kind of goes along with what you're saying. What is this? What does the graph do from here? Up and down wise. And what does it do from here? Up and up. It only goes up. It doesn't. And what is this one's y value? Since we're talking about the range, it's 0. Does the graph go below 0? Never. So just like what you were saying, your y values are only greater than or equal to, that's what that symbol means. It has the equal to bar, because it does touch the 0, just doesn't go below it. So your y values are greater than or equal to 0. That's what your range would be. You don't ever have a point where it's y is -1, because that would be down here. Now, this one, just like the last one, is also going to ask me these kind of questions. It wants to know, what is f of 2? So what this says, what number is inside the parentheses? That's always your x. So it wants to know, what is the y value when x is 2? Go ahead. Yes, it's another 4-part. Yeah, so this is, yeah. It's smooth sailing after this problem. Okay, so when x is 2, so here's where x is 2. So what you're looking for are any points that line up with that. So let's see what lines up with it. 3. This point, which is what? Good. Where the y is 3. So when x is 2, y is 3. And then the last part, for what x values is f of x equal 3. So I'm looking, what is f of x also called? Y, where y equals 3. So go to your y-axis, find the 3, then draw a horizontal line, because any point that lines up with that is going to have a y coordinate of 3, because it's going up 3. What is this one's x? 2. And it crosses through another one. And again, 2, 3, 4, 5, 6, 7, 8. There's 2 points that would have a y equal to 3. Okay, so that's problem 1 and problem 2. The rest of this section is just going to be talking about the domain. Instead of giving us a picture of the graph, it's going to give us the written out function without a picture. So when it does like that, when you're finding the domain, which is all the x values that can possibly be in the function, what you're actually going to be looking for is anything x could not be. Because once you find what x cannot be, then it can be all the other numbers. So let's talk about what kind of restrictions would be happening, where you would run into a situation like this, right? What is x not? It's not any numbers below 2. So that would tell me I have some restrictions. So the 2 main restrictions, and we're actually only going to see one of them in this section, is if you have a fraction with an x in the denominator, or if you have a square root with an x underneath. That's going to say, okay, this graph is not going to include all x's. You can't use every x. Because if you, and this is the only one we're going to see in this section, we will see this later though. So if you have a fraction, what can you not have in your denominator? What can you not divide by? 0. You can't divide by 0, which just simply means whatever your denominator is, if it has an x in it, you have to set that up and say, okay, this denominator can't equal 0. So for instance, whatever the denominator, you don't care anything about this number. You just care about this. X plus 2 can't, what's that? Cannot equal 0. And then solve it like a regular equation, which means you would have to subtract 2. So x wouldn't be able to be -2, because if you put -2 right here and add 2 to it, what are you going to get? you're going to get 0. So that's one restriction. Your denominator of a fraction can't equal 0. And what kind of numbers do you not want to see under a square root? Negative numbers, any number below 0. So if you had a square root function, you would have to then say, okay, x minus 1 has to be a positive, 0 or positive, which means greater than or equal to 0. Solve it for that x. So x would have to be greater than or equal to 1. Because let's say it was below 1. So let's just say 0, right? 0 is the first whole number below 1. What is 0 minus 1? Negative 1. You don't want to see a negative number underneath your square root. Okay? If I was going to do this in my calculator, let's do that square root graph. And I was graphing square root of x minus 1, and I graphed it. Look where it starts. It starts at positive 1 and goes to the right forever. What does it not ever do? It doesn't ever go below 1. So your x values are always 1 or greater. Because look, if I go to the table, so second table, look, your x being 1 is the last number that doesn't have an error, right? All the numbers that are below 1 all have an error just because they're not part of the graph. Okay, so that's what you're doing on these. So let's look at number 3. Those were just examples. Now we're actually doing number 3. F of x equals 6 over x plus 14. All right, so I do have an x in my denominator. What can your denominators not do? That can't equal 0. So set it up equal to 0 or not equal to 0. Solve it for x, which means subtract 14 from both sides. So what can x not equal? Negative 14. So the way, and this is going to be a multiple choice. So this is going to say x is a real number and x cannot equal negative 14. That's the only number that x can't equal. This x is a real number means it can be all the other numbers on the number line, just not negative 14. Number 4, p of x equals 2x minus 5. First of all, what kind of graph is when x is just an x? It's a line, right? Don't lines, well, unless it's vertical, but other than that, don't they go forever left and right? Yeah, there's no reason, because this doesn't have any restrictions. Because if you were making your own XY chart here, is there anything you wouldn't be able to plug in for that x? Can you multiply? What are you going to do to all the numbers that you put in for x to find the y that goes with it? You're going to multiply it times 2 and subtract 5 from it. Is there any number that you can't multiply times 2? No. You can multiply, you can just get a 0. But you can multiply any number times 2, and then you can also subtract 5 from all numbers. So, and again, what kind of graph would this make? It'd make a straight line like that. Uh-huh. Uh-huh. Yeah, if, well, I will tell you this, if X is just an X, it's always going to be a line. The domain's going to be all real numbers, always. Like a V. So if you had a, and we are going to have an absolute value in here in just a minute. If it's absolute value, it'll be that shape. You're not going to have all the range, but you are going to have all the domain because it goes forever left and forever right. The X squared graphs are like that. Again, your domain is going to be all real numbers because it goes forever left and forever right. These both, start here and both go up. So your range is not going to be all real numbers, but your domain will, because they do both go left and right forever. The other graph that we see is an X cubed graph, which is like this. Oh, look at you. Oh, wow. There you go. So what does an X cubed graph look like? It's the squiggle. And this one does go forever left, forever right. So its domain is also all real numbers, and so is its range, right? Because it goes forever up and forever down. So all of these, the domain is all real numbers. X squared, X cubed, plain X, absolute value of X. All those graphs, the domain is all real numbers because they go forever left and right. This one doesn't, right? Because it doesn't go forever left. It just goes forever right. Another one that doesn't is one like this, right? What that makes is a graph that goes like that. It's called a rational function. And there will be a part right here where it doesn't have an X, doesn't have a point. And it wouldn't have a point where the X was -14. But a rational function looks like that on a graph. So those are the ones that the square root and the rational functions are going to have a restriction on your domain. Yeah. All right, so what is this one? It's going to be multiple choice, and I actually like it when it says X is all real numbers, but the thing that you would choose is X is a real number, and that's it. It doesn't have this part, right? It doesn't have a part where X doesn't equal. All right, so that's 3, that's 4. Let's look at 5. P of X equals X squared plus 2. What kind of graphs are X squareds? Not circles. A parabola? Yeah, a U or parabola. So this one would actually be, look like that, right? If it's X squared, it's going to be all real numbers because it's going to be a U. It's going to go forever left and right. All right, number 6, G of X equals 9 over 6 minus 5X. So we do have a fraction, and it's got an X in its denominator. So what do I need? It is going to have a restriction. I need to say, well, 6 minus 5X cannot equal 0, because that makes it undefined. You can't divide by 0. And then use equation solving skills to get that x by itself, which means get rid of positive 6 with subtracting 6. Let's use negative 5x cannot equal 0 minus 6, which is negative 6. Whatever's hooked on, you divide by. So I'm dividing by negative 5. So x cannot equal negative over negative, just turns that to positive 6/5 because that doesn't reduce. So x is a real number. And, right, this one has a restriction, x can't equal 6/5. So this graph, if I graphed it, it would look like this. And it would have a spot that went right here at positive 6/5, which is just a little more than 1, where it skipped over it. It didn't have a point there. Number 7, find the domain of this. P of x equals the absolute value of x minus 4. First of all, what kind of graph is absolute value? V. Do V's go forever left and right? Yeah, so this domain is all real numbers, okay? Because if you think about it, if you're plugging in for x, what are you going to do to it? You're going to take the absolute value of it. And it doesn't matter what that number is. You can tell how many spaces away from 0 it is, even if it's a fraction, if it's negative, if it's positive, if it's rational, irrational, there's all kinds of things you can think of. You can still tell the absolute value of it and then subtract 4 from whatever that is. There's nothing you wouldn't be able to do that to. So x is a real number, right? Because if you were graphing this, it would start here at negative 4 and go up and right and up and left.
So in real life application, when do you use absolute value? Like when would you use that?
The main thing that I would say for that is when we get into dealing with exponential functions, okay? Exponential functions look like this. What makes this can sometimes flip across the y-axis like that, and that is if the number in front of that x squared, if the absolute value of it is greater than 1, so if it's either 3 or negative 3, it's going to be this way.
Okay.
If the absolute value of this is less than 1, like 1/2, because both of the absolute values of these are 3, right?
Yes, sir.
So it doesn't matter if it's positive or negative. If the absolute value of it is less than 1, so for instance, 1/2 x squared, that'll flip it across the y. Let me look more into that. Yeah, okay. Yeah. And get you a more real life example of that.
Okay. Thank you.
But that's one that we will use. All right, last one. Number 8. P of x equals x cubed minus 9. What do x cubes look like? Squiggle. Is there any number that you can't plug in for x and cube it? Can you multiply out all the numbers times itself 3 times? Yeah. Can you subtract 9 from anything? Yeah. And it's also the squiggle shape. And that squiggle shape its domain and range are all real numbers, right? Because they go forever left and right for the domain and forever up and down for the range. So this one, X is a real number. All right, any questions on this part of domain? Okay,